So now let's dive into some of these questions here. Now these questions are going to be in direct relation to the information that we see before, and through these questions I'm going to start to explain exactly what's going on here. Example 1. For each of the functions given below, how do the factors in the equation reveal the features in the graph? So we notice the word factor. What we're going to do is the first thing we're going to do is we're going to take this and we're going to factor it. So I get a at x equals, I take the x out of the top, which will give me x plus 2, and I'm going to factor the bottom right here, which is going to give me x minus 2, x plus 2. Now you guys will see on my right hand side, I just have all the information that I'm going to be looking for right here. The vertical asymptote, the horizontal asymptote, the x-intercept, the y-intercept, and the point of discontinuity. Starting off, well, let's start with the horizontal asymptote because that was the last thing that we really talked about. Looking at the graph right here, or looking at the function right here, I see that the power on the top matches the power on the bottom. Or rather, the degree on the top is 2 and the degree on the bottom is 2. That tells me that all that I have to do is divide the lead coefficients. So my lead coefficient on the top is 1, my lead coefficient on the bottom is 1, so that means my horizontal asymptote is just simply going to occur at y equals 1. Next thing that we're going to look at, let's look at the x-intercepts. Well, let's go back actually a bit. Let's look at the point of discontinuity, because one of the things that you guys may have noticed is that this x minus 2 is going to cancel out. So if that x minus 2 ends up canceling out, well, that's going to give me x all over x minus 2. Since it canceled out, and we said that my point of discontinuity is also known as the removable discontinuity, well, my point of discontinuity is going to have an x value of negative 2. Now, how am I going to find out what the subsequent y value of that is? Well, once I canceled out what would make it equal to 0, I'm just going to substitute that negative 2 into the equation right here. So I'm going to end up, I'm just going to write this up in the top corner right here, little scratch note. I go negative 2 all over negative 2 minus 2, which is going to give me negative 2 over negative 4, which will end up giving me 1 over 2. So that will give me a point discontinuity, or point of discontinuity, of negative 2 comma 1 over 2. The next one that we're going to fill in, let's look at the vertical asymptote. My vertical asymptote, well, the negative 2 got taken by the point discontinuity, so my vertical asymptote is just going to be at x equals 2. Now, my x-intercept. My x-intercept is going to occur when this function equals 0, or specifically when the numerator equals 0. The numerator tells us where the function will equal 0. The denominator tells us where the function won't exist. So when will the numerator equal 0? When x equals 0. Now, very, very importantly, we have to remember that since this point canceled out right here, even though the point of discontinuity is on the x-axis, so there will be an open circle on the x-axis, that point does not exist, so we don't call it an x-intercept. Finally, I want to find out what my y-intercept is going to be here, so I'm just going to quickly solve this for 0. I go 0 equals x all over x minus 2, or that gives me, whoops, sorry about that. Just going to quickly go back in time right here. Rather, I substitute 0 in for my x, so I go a at 0 equals 0 all over 0 minus 2, or I get that my y-intercept occurs when y equals 0. And that's all the information that we can get from this at this point in time.